This is a snow day video for Algebra 1 for Tuesday, I think it's October 29th. Hope you're all doing well today. We're going to work through Unit 3, Day 5. And so take just a second here, pause the video, and work on this DMR. All right, so here are some solutions for this DMR. First one is to translate. And as I read through this, the first key word that I come up to is the word product. Product means to multiply. So the product of 5 and x, so that means 5 times x, or you could just write that as 5x, is less than. That's the next key phrase that I see. So is less than means this. And then it says this last piece is a little tricky. It says twice the difference of x and 3. So twice means 2 times. And then it says twice the difference. So it's not 2 times x, and it's not 2 times 3. It's 2 times the difference of x and 3. So I'm going to need to use parentheses. And then the word difference means subtraction. And so I'm going to subtract x minus 3. And that would be my final translation. Like I said, you could clean it up a little bit. You could write it as 5x is less than 2 parentheses x minus 3. It's really the same thing. I don't really see much difference between the two. So either one would work. Okay, 2a. Find the slope of the following line. Well, the easiest way to see this would probably be slope-intercept form. So I'll put this into slope-intercept form. So 5x minus 3y equals 10. My first step would be to subtract the 5x over to the right side. My goal is to get the y by itself to be in slope-intercept form. This would give me negative 3y equals 10 minus 5x. My next step then would be to fully get the y by itself by dividing everything through by negative 3. So this would give me y equals negative 10/3 plus 5/3 x. And let's remember that the slope is always the coefficient on the x. So I'd say that my slope is 5/3. All right, 2b. It says write the equation of a line in slope-intercept form of a line that passes through the point negative 8, 3 and is perpendicular to 8x minus 2y equals 10. So if you remember, the two things that we got to have to write the equation of any line are the point, a point that the line goes through, and the slope of the line. So my point is negative 8, 3. But my slope is not terribly obvious. We are told that my line is perpendicular to this other line. So my first thought is, if I could figure out the slope of this other line, that might help. So I'm going to go ahead and try that. So to figure out the slope of the other line, I need to put it in slope-intercept form. So I'll write 8x minus 2y equals 10. And just like we did in 2a, I'm going to subtract the 8x over. This will give me negative 2y equals 10 minus 8x. And then I'll divide by negative 2 on both sides. This will give me y equals negative 5 plus 4x. Okay, so the slope of that line is 4, but I'm told that I want my line to be perpendicular to that one. So perpendicular lines do not have the same slope. Perpendicular lines have slopes that are opposite reciprocals. So my slope will be negative 1/4. Okay, I'm going to erase my work that I used to get that just so I have a little more space. Okay, so now that I have my point and my slope, I'm going to use point-slope form to help me get started. I have y minus 3 equals negative 1/4 times x minus negative 8, which is really x plus 8. And then I will distribute and I'll take that back. I'll just add right here. So after I distribute, I'll add the 3 over. This will give me y equals negative 1/4 x plus 1. and that would be the equation of my line in slope-intercept form. For number 3, hopefully you recognize this as something that we worked on a lot last week. It says solve the system of equations. It does not tell us a method. I would say based on the way this one is set up, I think substitution is best, and here's why I think that. Notice on the top row here, this first equation, notice how the y is already by itself. This is our setup for substitution. This is going to make substitution easiest of all of our options, and so I'll use that. What I'm going to do is in the other equation, the second row, I'm going to remove the y and replace it or substitute in for it. So it's going to be 2x plus, I've removed the y, it's not there anymore, equals 49. What is the only thing I can put in place of the y? Well, it's what the y is equal to, and that would be negative 5x plus 7. So again, what I've done is I've replaced this y with what the y is equal to. Y equals negative 5x plus 7, so I can swap one for the other. Once I've done this, I got a little simplifying to do. I add my like terms, and now I'm in a good place to solve. So I'll subtract 7 from both sides. That gives me negative 3x equals 42. Dividing by negative 3, I get x is equal to negative 14. And as you know from before, this is a good answer, but it's only part of it. It's incomplete because the solution to a system is a point, the point of intersection. I need to find the y as well. So I'm going to plug in to do this, and I will plug in to this first row, this first equation. So that would be y equals negative 5 times negative 14 plus 7. That's 70 plus 7, which of course is 77. So my point of intersection, my solution to the system is negative 14, comma 77. Okay, hope that DMR went well for you. We're going to look at a couple of application problems of systems here next. Go ahead and flip over to the next page. Okay, so we have 3 examples here for us to work through, and these are all going to be application examples. So take a minute and read through this first one. Hopefully the setting, the context will make sense to you. But we basically have a team that's getting photographs, and there are various packages allowed or offered for people to buy. The first package includes a team photo, 1 team photo, and 8 individual wallets for $29. And the second package offers 2 team photos and 1 individual wallet for $35.50. And we are supposed to find the cost of 1 team photo and 1 individual wallet photo. So what I'm going to do is I'm going to try to translate, as we've worked on before, the red sentence first. So it says the first package includes 1 team photo and 8 individual wallets. So I don't know how much a team photo costs, and I don't know how much an individual wallet costs. So I'm going to set it up and say that the team photo costs X dollars. So cost of team photo is X dollars. And I'm going to say that Y is the cost of an individual wallet photo. Okay, so according to the red sentence, the one that's highlighted in red, the first package involves just a single team photo. So I'm going to say the cost of that would just be 1x. And it also involves 8 individual wallet photos. So I'm going to say that the cost of all of that would be 8 times y. If you have 8 of them and they each cost y, well then the total cost would be 8 times y. To get the total cost of the whole package, I'm going to add these two, and I'm told that that total cost would be $29. And then I need to translate the orange sentence. The second package offers 2 team photos. So now I don't just have the 1 team photo, I've got 2, so the total cost there would be 2x. The 1 individual wallet, well, that would just be 1 times y. To get the total, I would add up those costs. And I'm told the total cost for that package is $35 and 50 cents. So then it's simply a question now of using some sort of a systems method to solve. You could use substitution or elimination. Because we use substitution in the DMR, I think I will choose to use elimination here. I need to create the pattern of opposites, which I don't have right now. So my strategy would be to multiply the top equation by a particular number. I want you to think about what that number is. And I think what I would do is I'd multiply the top equation by -2. And I'll write the result down here. So if I multiply through by -2, I get -2x minus 2y equals -58. Notice how I multiply that -2 times all of the pieces, all the different terms in the equation. Now that I have the pattern of opposites, I will add. The x's are eliminated, just giving me a 0. And when I add up the y's, I get -y. And when I add up the constants, I get -2250, I think. Yeah. Okay, so then I would divide everything through by -1. This would give me y equals $22.50. As I look at this, I realize I made a mistake. Maybe you already saw it. Let me go back. I made a mistake in my multiplication. This was unintended. So this is a nice object lesson on how you handle this. So I need to erase all this stuff because I multiplied wrong. I just multiplied in the wrong row. So if I multiply here, that is -2x. If I multiply here, it's actually -16y. So let me fix this. Get back on track. So -16y. Okay, so let's try this again. I did do this one right. Okay, so I still get 0 here. The x's are eliminated. I get -15y now. And over here, I still get -2250. So this time when I divide by -15, I get y is equal to 1.5 or $1.50. So that means the cost of an individual wallet is $1.50. And then I still have to find the x. So I think I can use any one of my equations. I think I will use this first row, this top equation. So if I plug back in, I get x plus 8 times 1.5 equals 29. So this would be x plus 12 equals 29. So x equals 17 after I subtract the 12 from both sides. So we would say that the team photo, $17, and the individual wallet photo is $1.50. Okay, so I feel like for the most part, in spite of my numerical mistake there, the hard part is often to set these up. So if you need to go back and review how I set this one up, feel free. Make sure that you can handle the details of the elimination, or maybe you chose to do substitution in a situation like this. That's fine too. Hopefully this worked for you. Keep at it until you get it. Let's take a look at a couple of other examples. Okay, number 2 says, a pet owner wants to make a rectangular dog run from 28 feet of fencing. If the length of the dog run is to be 10 feet longer than the width, find the length and width that is enclosed, of the area that's enclosed for the pet. I think a picture here is a good idea. So I'll draw this rectangular dog run, and we'll try to label some sides. I know that I've got a total of 28 feet of fence, so that would be all 4 sides. So if I think about all 4 sides added up, it's got to be 28 feet of fence. The length of the dog run is to be 10 feet longer than the width, and I don't know the width or the length, and so in math, if we don't know something, we usually label it with a variable. So I'm going to say that the width is x, and then I am told that the length is to be 10 feet longer than the width. So if the width is x, then I would say that the length would have to be x plus 10. Okay, so we know that with a rectangle, opposite sides are the same length, and so that means this side would be x as well, and this other longer side would be x plus 10. Okay, so if I have 28 feet of fencing, like I mentioned earlier, if I'm going to add all this up, I'd be using all 28 feet of fencing. So I would write x, it's this one right here, plus the other x, it's this one right here, plus this side would be it'd be an x plus 10, and plus the final side. If I add all these up, I would be using all of my fence, and so all those side lengths added up would give me 28. Got a nice equation right here that all I have to do now is add some like terms, do some simplifying, and I'm good. I've got 4 x's, so that'd be 4x. 10 plus 10 is 20. Now it's just a question of solving, so I subtract the 20 from both sides. 4x equals 8. Dividing both sides by 4, I get x equals 2. So that means it wants to know the length and the width. So my width would be 2 feet, and my length then would be 2 feet plus 10 feet, so that would be 12 feet. Okay, we've got one more to do here, but again, if any of this didn't make sense, I would go back and double check and see if you can pick a few more things up. All right, so our final example here is number 3. It says a plumber needs to cut a 16-foot pipe into 2 pieces. The longer piece is to be 1 foot longer than twice the shorter piece. Find the length of each piece. I think a picture here is also a good idea, kind of like on the last one. So, say the pipe looks like this. It's 16 feet long, of course. It's cut into 2 pieces. So I'll just let this represent the cutting of the pieces. The longer piece is to be 1 foot longer than twice the shorter piece. So, and I think I'll set this one up using a system. You could definitely do it without, but I'll use a system here. So I'm going to call the short piece x and the long piece y. Okay, so to use a system, I need to develop 2 equations. And the first one is just straight from the picture. I would say that the short piece plus the long piece has to be 16. And then the other equation would be generated from this statement that I'm highlighting in red, which says the longer piece is to be 1 foot longer than twice the short piece. So the long piece is y, and that is 1 foot longer than twice the shorter piece. So twice the shorter piece would be 2x, and 1 foot longer than that would be plus 1. So like I said, you could set this up without a system, but because we're practicing systems, I thought I'd set this up with a system. Okay, so you could choose elimination or substitution, and I would say that substitution is the easier way to go here because this second row, the second equation, already has the y by itself. So what I'm going to do is in the other equation, I will replace the y with what the y is equal to. So the y is now gone, and I can replace it with 2x plus 1 because that's what y equals, right? I can only substitute something of equal value for a variable. So from here we have some simplifying to do. 3x plus 1 equals 16 as I add my like terms. And hopefully this is looking very familiar. I would subtract 1 from both sides and get 3x equals 15. I would divide both sides by 3, and I would get x is equal to 5. So that means the shorter piece is 5. Five feet long. And then the longer piece, I just need to plug back in, and I will use this equation to plug back in. Y equals 2 times 5 plus 1. So that's 10 plus 1, which is 11. So the long piece is 11 feet. Okay, So I hope that went well for you. Thankfully, you've got this video, so if you need to go back and rewatch and rethink, you're welcome to it. And who knows if we'll have school tomorrow, but if we do, I'll see you then. If not, I'll see you later on. Please do remember that our Unit 2 test is this Friday. So I'll write this off to the side here for you. So you want to be working on that. And then remember that we have a review on Thursday, a review for that Unit 2 test. And then keep in mind that your big review WebAssign will be collected for a grade. So today with being a snow day, you could take a little bit of time of that and you could get quite a bit done on that. I think that would be a very wise move on your part. It's a fairly large assignment. I think it's about 50 questions, and you'll have time on Thursday to work on that, but getting some of that done today and possibly tomorrow, if we happen to have another snow day tomorrow, would be a great idea. The last thing you want to do is show up on Thursday not having done any of it. That'll be setting yourself up for a lot of work on Thursday and Thursday night. So anyway, I hope you're doing well. If you have any questions about any of this, feel free to email me. I'll check my email periodically throughout the day. See you soon.